Hello everyone, welcome to another video of Q programming. Today we will be covering data types in Python. This is a part of the introductory course of the Python that we are doing as a Q programming team, and this is an introductory level video, which means I'm assuming you have no prior knowledge about data types in Python. So let's get into it. When programming, one has to deal with different kinds of data, and it is useful to know how to use each of these. So in the context of Python, we'll be covering some broad data types in this video, namely numerical data types, sequences, sets, non-type, mapping dictionaries, and then at the end of it, we'll talk about the type function. So let's get into it. Now, firstly, we have numeric data types, which are, as the name suggests, they can hold numerical values. So numeric data types are classified into three kinds, which is integer, float, or complex. So first we have integer. Now as the name suggests, they store integer values. So it can be any negative integer, positive integer, or it could be zero as well. So it can be like -8, 9, 0, 2, 10, anything. As long as there's no decimal part to the number, it is an integer. And it can be negative or positive. So Python allows variables to store integer data types in such a manner. Suppose x equals to 10. This means I have created a variable x that stores the value of 10. And 10 here is an integer. I know that because I have not added any decimal point to this. So I can print x and I can print x plus 5. Now again, integers, you can perform basic operations in them such as addition, subtraction, and all of that. So if I show how this will play out, it will first print 10 and then it will print whatever the sum of x is with 5, which is obviously 15. So that's about integers. Let's move on to float. So in float is any value that has a decimal point in it. So it can be any negative or positive value, but it has to have a decimal point. So it can be 9.8, it can be 2.4, it can be 3.1, it can be minus 3.2, whatever. It has to have a decimal. That's the only condition for it to be a float data type. And even if I'm writing a number which is not supposed to have a decimal, as if I'm using float data type, I must include the decimal point. So even if I want to write 4, I'll have to write 4.0. This is a must if I'm talking about float data type. Let me give an example. If I write x equals to 5.6, and if again, let's first print x, this will print 5.6. And if I now again, float are also a numeric data type, so you can perform arithmetic operations like x minus 2, and this should print 3.6, which is what is printed very approximately. So this is how float data types work. And this is mentioned in the Python documentation that the float data type is only accurate until a certain point, after which it is not working because the computer cannot process and convert it to binary. And this is mentioned in the documentation of Python. And one more thing about floats is that you can also do scientific notation with them. Scientific notation is when you write one number between 1 and 10 and then multiply it by a power of 10. So if I write x equals 5.62 E4, this means I am multiplying 5.62 with 10 to the power 4. That's what the E signifies. So if I run this and if I say print x, you will see that the decimal point moved 4 places ahead and hence 2 new zeros came up. And this is what E4 means. That means it's raised to the power 4, 10 multiplied by 10 to the power 4. So that's about float data types. Now we will talk about complex numbers in Python. So complex numbers, as many of you might know from mathematics, has a real part and an imaginary part. Now in math, we represent the imaginary part with iota, but in computer science and in programming, we represent it through a j. So if I write z equals to 3 plus 4j, this means the real part of my z is 3 and the imaginary part is 4. And I can even extract these values using two functions, either print z dot real or print z dot imaginary, imag for that. So as you can see, it printed the real part and the imaginary part simultaneously the way I asked it to. So this is one way to extract it, and again the way you can perform arithmetic operations on complex numbers in mathematics, you can do the same thing in programming. If I say z1 is 3 plus 4j and I say z2 is minus 5 plus 9j, and if I print z1 plus z2, you can see that the real part got added to the real part and the imaginary part got added to the imaginary part. So hence we can see that this is how complex numbers work in Python. Now let's talk about conversion functions. There are three conversion functions when we talk about numeric data types, which are int, float, and complex. So as the name suggests, you can convert one number from one data type to another. For example, if I have 11 by 2, we know that is 5.5, but since I've put inside the int function, it will not consider the decimal part and it will simply print 5. The float part, now let's look at this example, print float 2. Now I have not provided a decimal part to this, but it will add it itself because this is a float data type. Now I said print float 22 divided by 9, which is this decimal, and it will print it accurately up to a lot of decimal places because it is float, and that's how float works. Complex data type has to have a real part and an imaginary part. So if I write print complex 4, it'll write 4 plus 0j because the imaginary part is 0 in this case. That does not mean that that because you've written complex there, it will have to write something in the imaginary part, which is 0 in this case. And obviously for any other complex number, it will just print the complex number the way it is. Okay, now that we have finished numeric data types, let's move on to sequences. Now there are three kinds of sequence data types that Python offers: strings, lists, and tuples. Let's go over these one by one. So at first we have strings, and strings are represented by quotation marks. It can be a single quote, it can be double quote, or it can also be triple quote. So single quote and double quote are usually used for single line comments, and triple quotes are used for multi-line comments. For example, if I have x equals to abc, just for example, y equals to xyz, and z equals to a triple line quote, hello there, multi-line quote, yeah. And then I'll print all of these. So see, in the first one, which is a multi-line comment, I printed ABC. I have ABC in double quotations and in single quotations, and I've shown all three basically. So if I run this, you'll see that they're just printing the way they are. So either of these ways works in strings. A few things to remember about strings are that they're immutable, meaning you can't actually change the value of a given string. You can change the value that it's assigned to the variable with, but you can't change its individual value. And one more thing is you need to be consistent with which quote you're using. So if you start with a double quote, you have to finish with a double quote. I can't do this. This is wrong. And the Python interpreter won't be able to run it either. It will return a syntax error. So do not do this. Use the same one that you started with. And one more thing, you can concatenate strings. So if I have hello and y equals to there, and I'm putting a space here so that it looks fine, and I print x plus y. What it's doing is it is joining the strings together. It is putting them one after the other. That's what concatenation means. And this concatenation can be done between any two strings or more than two strings also. So this is how it works. And if I don't put this space, you can see what happens. It just joins them the way they are. So I put this space there to give a notation that they are two different words. But what the Python is doing here is just simply combining the two strings. Now let's move on to lists. Now lists are an ordered collection of data. How they work is they are put in square brackets, meaning you put them in such a manner. For example, if I have x equals to 2, 3, 4, 5, 9, ABC. So they can contain any sorts of data type. It can be integer, it can be float, it can be anything. So if I put this and if I print x, it will print the list the way it is. And remember one thing, that you should, like, it is always recommended to use the same data type throughout the list, even though it is not syntactically incorrect. Like putting a string after a pair of integers is not what is recommended, although it is not wrong. Because consistency is one thing that is good to have when you're using lists. Few more things to remember about lists are that they are mutable, meaning we can mutate the list, we can change values in it. Okay, now let's move on to tuples. Now, tuples again are an immutable data type and they are represented by circular brackets. So if I have x equals to 2, 3, 4, this is a tuple, I can print x. Let me do that. Yeah, I can print the tuple. And remember, one more thing about tuples is, again, they are immutable unlike lists. In lists, you can actually change the value of a specific element, but you cannot do that in tuples. Now, let's talk about indexing. So I'm just going to pull up a chart that shows how indexing works, positive indexing and negative indexing. Pause the video to see it. Now let's use it. So if I have x equals to 2, 3, 4, 9, 10, 8, suppose this is a list. And if I want to access the third element, I think you could see from the chart that would be placed on index 2, the positive index 2, because it starts from 0. So 0, 1, 2. So if I write print x2, I will get the third element. Okay. So if I run that, you'll see it prints 4. And this doesn't just work with this works with all sequence data types. You can do the same thing with list. So if I have, you can do the same thing with strings. So if I have this string, I can print y9, suppose. And it printed r because this is at the 9th index from the beginning, starting from 0. It has at the 10th position but the 9th index. And I can do the same thing with tuples as well. And this will print 9 because it is this is at index 2. So this is at index 0, this is at index 1, this is at index 2. So it printed 9 accordingly. So that is how indexing works, and this works for all sequence data types, which are strings, lists, and tuples. And now let's talk about conversion functions like we did for numeric data types. So just the way there were with numeric data types, there are 3 conversion functions here: string, list, tuple. So let's see how we can use these. So now, for example, I'm going to start by using an integer value for a string. So if I have x equals to 11, we know this is an integer. If I print string x, it will print 11 because it is the same thing. But remember, now it is printed as a string, so it will work the way a string works. One thing I can show to make you explain and make you understand that if I have this x equals 11, y equals 12. If I print x plus y and if I print string x plus string y, first in x plus y it just added the two numbers and printed 23. But in string x plus string y, it joined 11 and 12 together because now these two are strings. That's what conversion means. You can convert from any data type to string and it will work the way a string works. So I did both of these to show you the comparison between the two and why they are different. Now you can do the same thing with lists and tuples. So if I have a string s equals to a b c d e f, and if I do print list s, you'll see what happens is that each element of the string gets put into one element of a list, and the list is printed. This is a very useful trick, and you can do the same thing with tuples. And yeah, you can see that's what happens. Alright, now let's move on to sets. Now sets are different from sequence data types because all the sequence data types are ordered. That means they have indexes. Sets, on the other hand, does not follow an indexed value system. It is just a collection of data that is represented in curly brackets. Right? So, as many of you might know from maths, and maths also set theory, if any of you studied set theory, you would be aware that sets are represented by curly brackets. And you can do the same thing here. So if I have S1 equals to 2, 3, 4, 5, this is a set, and I can print it, it'll print it. Now you can add items to this set in the following manner. So if I write print s1 dot add 8, now you'll see that 8 got added to the set. But if you might know that set has a property, no repeated elements must be there. So any repetition will be null and void, and it will only show it once. For example, I can simply just write, if I write 5, add 5, it will not reflect any change. Why is that? Because any repetition is not considered. It will just print whatever repeated things are there once. That's how sets work. And if you want to add more than one item, you can add it using a list, and the function is update. So s1.update, you put a list and it will add all those items. So if I want to add the numbers 10, 11, 12, 13, and now if I print s1, let's do that. You can see 10, 11, 12, and 13 got added to s1. First we added 8 using the add function, and the update function lets you add more than one element, and the parameter in it is a list. That means you have to pass a list and it'll add all of those inside the set. There's one more function called union, which will require two sets. So if I have s1 equals this and s2 equals to, let's say, 8, 9, 10, 11, and let's put one repeating element as well, 4. Okay, so if I say set3 equals to set1 union set2, set1 dot union set2, that's how it works. So what will happen is it will join both the sets. Wait, I should call this set. My bad. Yeah, so what will happen is it will join the two sets, right? And any, like you can imagine, any repeated element will be gone, and it'll just simply join the two sets the way they are. So you can see what happens here. I need to print set3, and you can see what happens. I added 4 as well as in the union, but it didn't come. What came instead was the new elements, and they got added in set3 as well as this got added. So the union is a mathematical operation that can be performed on sets. If any of you studied set theory, you would know about this. And we can do a lot more things with sets which require the knowledge of set theory. So if you do not have some basic knowledge of set theory, you can go to our website. We have course material available for that. Okay, now let's talk about non-type data. This is used when we do not want a variable to have any data, it's just none. So if I say a equals none, like you can see this became blue. This is because this is a unique data type which stores no value at all. And this is useful in programming when you want something to just have no value at all. So none type data is used for that, and if I print a, you can see it prints none, right? So there's not really much to tell about it. Now let's move on to mapping data types, which is dictionary. Now what is a dictionary? It is a system of keys and values where you can map one value to another. So keys are what are the placeholders, and values are the actual values that the keys hold. Let me give an example. If I use dict1 equals to, say, apple 10, banana 20, orange 30. Suppose this is how much of each fruit I have in a specific shop or whatever. So apple is the key here and 10 is the value. So in totality, this is how you map one key to a value. This key, banana key, is mapped to this value, and this key is mapped to this value. So if I want to extract elements, instead of using indexing like we did in sequences, this is not how it works over here. Instead of that, I will use the key that I have given. So suppose I want to know how many bananas I have. I will say dict1 banana print dict1 banana. Let's do that. Let's print it. And it will print 20. So this is how you can actually extract. So dict1 banana basically is telling you how much I have, 20. I can do the same thing with any other key, orange. So one thing to remember about dictionaries are that they are a mutable data type, meaning you can change values in it. So let me demonstrate with an example. If I want to say make apples 5, so I'll do apple equals 5 like this. This is the syntax for it. And then I'll print the dictionary and you will see what happens. Sorry, I forgot that T over there. Ignore that. Yeah. So now you'll see that initially it was 10, but it became 5. How? Because I used this statement to change it. And over here, I have changed the value of the actual dictionary. So remember that dictionary can be mutated just the way lists and yeah, just the way lists can be, and sets also can be. Dictionaries can be mutated, and other than that, you can even add elements. So if I want to add, say, carrot equals to, let's say, 15 of them. Let's remove that. So what I have done here is I put a new key with a new value. So whenever this syntax for this and editing is the exact same, if you take careful look of it. So what happens is the computer will first look for this key in the dictionary. If it's not there, then it will create the key. And you'll see that carrot got added over here. So that's how dictionaries work in Python. And now let's talk about the type function. So as the name suggests, you use this function and it will tell you what type a certain data is. For example, if I have x equals to abc, we know this is a string. So if I say print type x, you'll see it prints class str, which is telling me, okay, this is a string. I can do the same thing with any other data type. I can do it with integers, I can do it with float numbers, I can do it with complex numbers, I can do it with lists, dictionaries, tuples, anything. I can even have a tuple here and you tell me it's a tuple. I can even put a list here. Suppose, and I can even put a dictionary. Let me take this dictionary and show you. So yeah, this is how the type function works. You can put it, and this is very useful in programming because later if you might want to have an input or some value in a very specific data type, you can verify this, and it will also help you a lot in debugging in case your program is returning an error and you're not able to get the right data type. So that's been my time. I hope you enjoyed this video. If you did, don't forget to like and subscribe to our channel if you're new, and keep tuned for more videos coming up for the Python introductory course. And thank you for watching, and all the course material is available on our website. Feel free to check it out. Link is in the description below.